In this lesson, we're going to be talking about solving multi-step inequalities. By the end of this lesson, you should be able to solve linear inequalities with more than one operation and solve linear inequalities using the distributive property. We're going to talk about the difference between inequalities and equations. For the last couple videos, we've been focused on equations with distributive property, combining like terms, and then solving equations with variables on both sides. But it's important for us to be able to recognize the difference and maybe even the similarities between an equation and an inequality. So in an equation, we have an equal sign. So it tells us that our solution is equal. They should be equal. But when we're talking about an inequality, we have what is known as an inequality sign. So this is the greater than or equal to, less than or equal to. So this tells us that what we're looking for should be either above or below, or maybe even equal to what we're looking for. When we talk about an equation has one solution because it should be equal to whatever number that you get. But when we talk about an inequality, because it could be less than or greater than, we have many options because there are typically many solutions or many numbers that are greater than or less than the number that you've solved for. In an equation, when you graph it, you're going to get a line, and your solutions are only the points that would be on that line. But when we are talking about linear inequalities, we have what is called a region. So we have a region where our answers could be located. When you're graphing answers to an equation on a number line, it's 1 point because it's one number. But when we're graphing answers or solutions to an inequality, it's a line. And the reason why it's a line is because we have many answers, many possible solutions that it could be. Remember that with equations and inequalities, that whatever you do on one side, you must do to the other side, and this is that property of equality or property of inequality. That way it keeps it the same as you're moving things around. It doesn't change the value of your equation or inequality. To solve an inequality, you're doing the same steps that you would for an equation. So remember that the first two things that we do is we distribute and combine like terms if necessary. Once we've done that, then we want to get variables on one side. We do this by adding and subtracting. And then we isolate the variable by multiplying and dividing. Remember that when you are dividing by a negative number, you must remember to flip that inequality sign. So when you divide by a negative number, the inequality sign gets flipped or reversed. Okay, graphing inequalities. Remember that when we're graphing, you're graphing them on a number line. So if it's an equation, it's equal to, when you're graphing it on the number line, you represent that solution with a point. But if you're graphing an inequality such as greater than or less than, you're going to have an arrow pointing either to the right or to the left if it's less than. And because it's greater than or less than, there's no equal to part to it. We use an open circle to indicate that we do not want to include the point that we start at. But if it's greater than or equal to or less than or equal to, it's going to look very similar to greater than and less than. But this time we're going to fill in our point. We're going to fill in the circle so that we indicate that we are indeed including the point where we're starting at. Okay, just a reminder that if you multiply or divide by a negative number, you must reverse that inequality sign. So if it was greater than, it's going to become a less than. All right, let's practice. We're going to solve the following inequality, and then we're going to graph. Now remember that our steps are to distribute, combine like terms, then we will add and subtract to get variables on one side, then we'll multiply and divide to isolate the variable. All right. So we have like terms here. We have -6, we have 7x. So -6x and 7x, those are like terms. So we want to go ahead and combine those. -6x plus 7x gives us 1x, or just x. which is greater than or equal to negative 4. So in this case, all we had to do is combine like terms. We don't have to add or subtract to get the variable on one side because it's already by itself. And because the coefficient in front of that number is 1, we don't have to multiply or divide to isolate that variable. So now all we have to do is graph our solution. So we're graphing on a number line. When I'm making my own number line, I'm going to start with, I don't have to put all the values there, I'm just going to put the one that I have, so I'm going to put negative 4. Because this is a less or greater than or equal to, I'm going to close in my circle. And we have x is greater than or equal to negative 4, so I want all the values that are to the right. So everything that's greater than or equal to negative 4. Those will be all the values to the right. Alright, let's look at another example. So here we have negative 3/4 p is greater than or equal to 6. So again, remember our steps for solving would be to distribute, combine like terms if necessary. We don't need to do either one of those because we do not have like terms, we do not have parentheses. Add or subtract to get the variable by itself. Well, we know the variable is already on one side by itself, so I don't need to do this step, so we can move straight to multiply and divide to isolate this variable. We have a fraction. We have negative 3/4 p. We need the p to be by itself, and so we need to get rid of this 3/4. Because this is a fraction, we're not necessarily going to have to divide here, but what we're going to do is we're going to multiply by what's called the reciprocal. So to get rid of any fraction, you multiply by the reciprocal. So the reciprocal of negative 3/4 would be negative 4 over 3. You're going to flip the fraction, so that would be the reciprocal. So on both sides of my equation, we're going to multiply by negative 4/3. The negative times the negative is going to make it a positive. The 4's on the bottom, the 3's cancel out, so you're left with just p. And then remember, okay, that we are multiplying by a negative number. We multiply by negative 4/3 on both sides. So because I'm multiplying by a negative number on both sides, we have to reverse this inequality symbol. So instead of greater than or equal to, now it changes to less than or equal to. And so we have p is less than or equal to, well, let's do this part. I know here that if I have 6 over 1, I can cancel out the 6 on the top with the 3 on the bottom. This becomes a 2, this becomes a 1. So I have 2 times negative 4, which is negative 8. So this would be my solution here. And then we're going to graph it on our number line. We start out at negative 8. And then we are using, again, we're using a closed circle because we are including it. And p is less than or equal to negative 8, so we want all of the values that are less than or equal to negative 8. Alright, so on this one we don't have to graph because it says no graphing. But what we're going to do is we're still going to solve it. So remember our steps for solving: distribute, combine like terms if necessary, add and subtract to get the variables on the same side, multiply and divide to isolate the variable to get it by itself. So here we do have to distribute. We have parentheses here, so we're going to distribute the 2 to both the t and the minus 7. So that will give us 2t minus 14 is less than or equal to positive 9. I don't have to write the plus here. So we have positive 9. And then what we're going to do is we're going to now, we don't have to combine like terms. I don't have any like terms. So I'm good with those. But we do need to add and subtract so that the variable is by itself, so that we get the variable on a side by itself. So we're going to have to move this 14 because the 14 is on the same side as the variable. Remember that to get rid of 14, we're going to do the inverse operation. The inverse of subtraction would be addition, so we add 14, and we need to add it to both sides. So now we have 2t is less than or equal to 23. And then we divide. and divide by 2 so that the t is by itself. And we have t is less than or equal to 23 over 2. You can convert this to a decimal, but it's not necessary. When we're working in math, we like to have exact answers, and fractions are not always exact. Alright, let's look at another example. This one we're going to write and solve the inequality. So we're going to have to look for the words that would trigger an inequality sign for us. So we have 3 times a number is more than the difference of twice that number and 3. So here, the is more than part does not mean that we're going to be adding, but this is telling us is greater than. So we have 3 times the number. That's multiplication, so that's 3 times. We don't know the number, so we'll just call it n. 3 times the number n is more than, so is greater than, the difference of twice that number and 3. So we have subtraction happening here, and the subtraction is happening between twice the number, so 2n, and 3. Alright, so here we have our inequality. We want to solve our inequality. Again, we don't have distributed property. We don't need to combine like terms. We do need to get the variables on the same side. So I'm going to move this 2n because the 3n is already alone on this side over here. So I don't want to move the 3n, but we do want to move this 2n. So to move the 2n, remember we're doing inverse. Inverse of positive 2n would be to subtract it or make it negative. That would cancel out there. That forms a 0 pair. And 3n minus 2n is n. And so what we end up with is n is greater than or equal to negative 3. Now I don't have to reverse the inequality sign here because we are not multiplying or dividing by a negative number. So just kind of remember that. We only change it if we're multiplying or dividing by a negative number. Okay, Nicholas wants to order a pizza, and he has a total of $13 to pay the delivery person. The pizza costs $7.50 plus $1.25 per topping. If he plans to tip 15% of the total cost of the pizza, how many toppings can he order? So we need to write our inequality here. We know that he has a total of $13. So what this tells us is that whatever he spends, whatever he orders, must be less than or equal to $13. Now, we know that the cost of the pizza is $7.50 plus $1.25 per topping T. And then he's going to tip 15%. Now, you have to be careful with this part because we are going to multiply to get with this 15%, but we're not going to multiply by 0.15 because 0.15 will not give us the total cost of the pizza. What we're going to multiply by is 1.15. The reason why we're multiplying by 1.15 is because we do have to pay the 100% cost of the pizza plus the 15% tip. So if you're paying the whole cost of the pizza, the 100% cost of the pizza, plus the 15% tip, that would add up to 115% of what the pizza costs, which would be 1.15. So this would be your inequality that you would solve. Then at this point you would distribute, combine like terms, and then you would have your solution there. And so in this particular case, he could order 3 toppings or less. Alright, we want to write an inequality for each graph. So here our inequality would be x is less than -1, and on this one it'd be x is greater than or equal to 2. Alright, before watching the next video, I would like for you to consider how we represent an inequality. So to represent the solution to an inequality, as usual, please subscribe to the video to the channel so that you get notifications of when new videos are put out.